Algebra 3, right? Let's click on that. We'll look and see in the grade book here. We are done with Module 5. So we're working on Module 6 now. We're starting with the first two lessons, February 12th, first two lessons. Notice we're going to spend just a few weeks on this. But this lessons next week, we have the hyperbolas and conics collage. And then we just have the practice exam and the exam. So this is a very short one. So remember, we'll accept late work until we test on the next unit. So February 26th, everything in Module 5 will be a permanent 0 if it's turned in. So late work for Module 5 is only turned in until February 26th, because that's when the test is due. And once we take the test on Module 6, Module 5 is closed. So nothing to be allowed on Module 5 after February 26th. So if you are missing assignments, get those turned in. And you need to keep up anyway. You don't want to get way behind, because then you forget stuff and you don't score well when you go back and do stuff that's a month or 2 months ago. So you want to keep up anyway. All right. So we're going to look at 6.01, 6.02. This looks a little different because we stole the curriculum from a different place. Algebra 3 is a class that Arkansas has that not a lot of other states have Algebra 3. They have different classes. They have trigonometry or some other classes that serve as another math credit. But we do Algebra 3 in Arkansas. So with the standards that we teach, we steal from Algebra 2. We steal from pre-calculus. We get our information from other classes to fill in everything that we need to teach in Algebra 3. So this one looks different than the last module because we took it from a different curriculum. On this, our lesson will just be on one page. This is a Google document I put together. Everything's on one page. And then you'll have the assignment on as usual. So let's look at this first lesson for 6.01. Introduction to conics. So what is a conic? A conic section is the intersection of a plane and a double napped cone. So a double napped cone is like in the picture here. Think of two ice cream cones put tip to tip, the bottoms of the cones put together there. So I want to show you over here where the conics are formed. So if you look at this, if you take a plane, P-L-A-N-E, not P-L-A-I-N. I mean, I guess you could fly a plane through a double nap cone, but it'd be a disastrous. If you take a plane and you cut it through a double nap cone, like where it's at right now, down low, right? It just makes a circle. You see the blue shape right there. That's the shape where it cuts through the cone. So that's one of the shapes. You can be bigger or smaller, depending on how high or low you are on the cone. If you're up on the other cone, just creates a circle. But as you tilt that plane, so let's tilt the plane. So as we tilt it, let's kind of turn it sideways. We can see how it's tilting. See, it's tilting like that. It becomes more of an oval. You see, that's an oval. It's an ellipse. Mathematically, we call that an ellipse, but it's an oval. But so anytime that the plane is, if it's 90 degrees, it makes a circle. If it's between a number and 90, which means less than 90, it's going to make an ellipse. Now, if we continue tilting it, we lose the bottom, and it just makes a parabola. Oh, that's still showing an ellipse. That shouldn't be an ellipse at this point. There we go. Now it's just making a parabola. As you see, as it cuts through the shape, see, it doesn't have a bottom to it anymore. And that's a parabola. And then if we continue on all the way up, depending on where the cone, where the plane is, let's move the plane up. See, now we've got a hyperbola because it's cutting a little bit out of each cone. You've got the top cone making a type of a parabola, and the bottom making a type of a parabola. Together, the hyperbolas, because you have both shapes. So these are the shapes we create: the circle, the ellipse, the parabola, and the hyperbola, as we take a plane and cut it through a double napped cone. So nice illustration of that GeoGebra provides us. GeoGebra is a good website for these type of illustrations. Yeah, we can spin it. Look at there. Woohoo. Fun stuff. But no, I wanted to show you that. So that's where these shapes come from. This illustration kind of shows it in a different way. ellipse, circle, parabola, hyperbola, but it's easier to show over here. So if we make it all the way up to 0, could make an X if we're right in the middle, but as we move that over, oh, that's making the cone bigger. We move that over. It doesn't want to move it over. This illustration doesn't want to move it over. All right, but you get the shapes it makes. So, all right, let's talk about the equations of a circle. So we know a circle is defined as the set of all points that are the same distance from a center, right? So the set of all points, the same distance from a center. So if we go back and look at that, 90 degrees, we'll move the plane a little farther down. We got a bigger circle. So from the center of that circle, all of the points in the circle are the same distance from the center. So that's the definition of a circle. And the equation of a circle looks like this. It's x minus h squared plus y minus k squared equals r squared, where h and k is the point that is the center of the circle. So when we have a circle that's on the origin on a graph, h and k is 0. So you just have x squared plus y squared equals r squared. And that's the traditional circle equation we see, as long as it's centered on the origin. But if the center is not on the origin, you have the h and k. And it's h minus the h and y minus the k to have where the center of the circle is. And r is the radius, right? So r squared is in the equation. R is the radius of the circle. So let's talk about a parabola. We know a parabola is made by a quadratic equation, but we can have a definition for a parabola as well. It's the set of all points that are the same distance, equidistant, same distance from a fixed line and a fixed point that are not on that line. It's like, what are you talking about? Well, I'll show you that in just a moment. Let's look at the vertex of a parabola. We're used to that. That is the midpoint between the focus and directrix, however. But the vertex is, the point where it turns, either the lowest point of a parabola or the highest point. The axis, they're talking about the axis of symmetry, is the line that passes through the focus and the vertex, and it's called the axis of symmetry. It's where it's kind of like a mirror. Each side of that line is like a mirror of the other side. So we can have an equation, and we'll look at the equation in a minute. Let's look at what they're talking about with the focus and directrix. I got another application right here. So here's a parabola. We have this blue parabola. And you see this point marked right here, 4, 2. That is said to be the focus of this parabola. And the directrix is the red line you see below. And it's y equals -2 is the equation for that line. Now it says the vertex is halfway between the focus and the directrix. So these are always the exact same distance. The distance from the focus to the vertex and the directrix to the vertex are the same. And we said the definition is the set of all points that are equidistant from the directrix and the focus. It's like, okay, what does that mean? It doesn't mean it's the same distance from the focus to the there and there, but it means when you, it does mean when you put those together. See, if we look at this, this is 9.08 away from the focus, and this is 9.08 from the directrix at that point right there. If I move that, watch, those numbers are always the same. It's the same distance to the focus as it is to the directrix. Look, when we put it right on the vertex, this is 2 away from the focus to the vertex, and it's also 2 in green. You can see 2 away from the directrix to the vertex. So these points are the same distance away from the focus and the directrix. It doesn't matter where we move it on the parabola. 10.56, 10.56. So these points, this is something new we haven't studied in parabolas before, are very important in the parabola there. So it stays the same distance away. So this is something new. We're gonna find the focus point. Now notice the focus point is inside the parabola. The focus point is always inside the parabola. If this was a downward facing parabola, then the focus point would be down inside there. and the directrix is always outside. It's on the other side of the vertex. So if this was a downward facing, the focus would be down here and the directrix would be up above it. So it's always outside and the focus is always inside. All right, so now let's look at these equations. Here's the standard form of the equation of a parabola. X minus h squared equals 4p, y minus k. P cannot be 0. So I'm going to switch over to my camera here. Let me do this. All right, let's put the camera up. And let's talk about what these equations look like. So if we're saying the standard equation of a parabola is x minus h squared equals 4p. Well, that's a new one. We haven't seen a p in these equations. We've seen h and k. Y minus k. And p cannot be 0. Okay, that doesn't look like the equations we usually see, right? We usually just see an x squared in there. Well, there is an x squared. See, we do have the x squared in the equation. So that does make it a quadratic equation. If this parabola has a vertex at the origin, if we're at 0, 0, right? If h and k are 0, because that is the vertex. The vertex is hk. If these are zeros, then it's just x squared equals 4py. Much simpler if it's a parabola that has the vertex at 0, 0. So we can work with that a little better. It looks like, okay, I understand that. They also give an alternate equation on there where they just divide by 4. They solve it for y. So you either have this equation, or if it's a y equals, if you like a y equals equation, well, the first thing you do is divide it by 4, and then you gotta move the p over, you gotta divide by p, and you gotta move the k over, and it ends up 1 over 4p, because you divide by 4, divide by p, times x minus h squared plus k. All right, so we divide by 4p, which you could also just put x minus h squared over 4p. That's the same thing as having it out front. But this is the same equation as this. It's just this is solved for y, because a lot of people like y equals in their equations. So this is actually looks simpler to work with than having to deal with the 1 over 4p. But you can use either one when you're writing the equation of a parabola. So let's talk about that p number. That p number. That is actually, if we go back and look at this illustration, I'll get rid of that one. P is actually that distance that's between the points. In this case, between the focus and the vertex and the directrix. Our P is 2 in this one that we have on the screen. You know, I make that bigger. I should have done that. 2 is the P in the equation, because that's the distance from the vertex to the focus, also the distance from the vertex to the directrix. So that distance that we use for all these points is the P when we compare the distance between the focus and vertex and focus directrix. So our P is 2 on that one. All right, so let's go back. Let's go back to here. So, all right, so we're going to take the standard equation and we're going to work a problem with it. And this problem wants us to find, all right, let me draw this across here. Oh, by the way, this is for, I guess I need to make sure you have this. This is for a vertical parabola, which means it goes up and down. Either it's an upward pointing or downward pointing parabola. That's what we generally work with, right? So this is the equation for a vertical one. If we have a horizontal, which is certainly a possibility, it'd be one that opens to the left or it opens to the right. So by the way, if P is greater than 0, it's going to open upward. That's that number up front. If P is less than 0, it's going to open downward. All right, because it'd be a negative out front. This would be a negative out front. Right? Remember, if we have a negative out front, it basically transforms it down, it flips it upside down, it reflects it downward. So if P is a negative number, you're going to have a negative out in front of the equation, and it flips it downward. On a horizontal one, it goes to the left if P is less than 0, and goes to the right if P is greater than 0. So if it's a negative equation, it's going to be a left-pointing parabola on the horizontal. The horizontal equation is similar to this. We just rearrange it a little bit. We put the y minus k as the squared, and it's 4p x minus h. So basically, we just take what's in the parentheses, and they trade places. So it's a y squared when it's sideways like that, instead of an x squared when it's up and down, y squared when it's left and right. And of course, you have the x equals 1 over 4p y minus k squared is the equivalent. These are the same equation. And again, p cannot be equal to 0, because if it's equal to 0, then this whole thing equals 0. You know, that would all equal. You can't have a 0 in the denominator anyway. So, and again, if it's at 0, 0, then the equation simplifies to just y squared equals 4px. Kind of like that one simplified, because these are 0. It's a y minus 0. So it's just y squared. Okay. Now let's look at this in the practical application of a problem like you might have on your assignment. We're given this equation, x squared plus 4x minus 8y minus 20 equals 0. And we're like, oh my goodness, Mr. Brock, what are you doing to us? Well, we want to find the vertex. And we want to find, oh, I lost it on there. Oh yeah, there it is. Okay, we want to find the vertex. We want to find the axis of symmetry. We want to find the focus point. That's a point. And we want to find the directrix line. So what are they? We're going to put colons there. All right, we want to find those 4 items, and we have this equation. So I'm going to take you back to something we call completing the square. I'm sure you haven't seen that in a while. Most people didn't enjoy it when they saw it the first time, but it's not so bad. We're going to get into completing the square here and just talk about an example. So let's say if we were completing the square, I'm going to put a box over here just outside this problem. If we had an equation that was a square, a perfect square trinomial, that's because we had 2 binomials that were exactly the same multiplied times each other. All right. X plus 3 times x plus 3. That's the exact same binomial. So that's just like, that's the same thing as x plus 3 squared. And when we multiply those together, we get what we call a perfect square trinomial. So when you multiply those together, you get x squared plus 6x plus 9. And x squared plus 6x plus 9 is a perfect square trinomial because it's created by squaring a binomial. So it's a special case. When you can square that, you get this. Now the question is, if you start with this, how do you get that? If we just had x squared plus 6x, and it equaled, well, in this case, it would equal -9. The way you make this a perfect square is you take that middle term and you cut it in half. All right, 6 divided by 3. I'm sorry, divided by 2 equals 3. We cut it in half, 3, and then we square that, whatever this number is, and you add that, plus 9. And add it to both sides because we're not changing anything. And that would equal this, plus 9 equals 0. To complete the square, you take whatever the x term is, cut it in half, and then square that. And then that tells you that this is the binomial number. So it must be a x plus 3. That must be the binomial that we're squaring to get that, because it's a 3. So with this, if we want to complete the square, we got to move everything that's not an x to the other side. So we're going to add 8y, and we're going to add 20. So we get x squared plus 4x equals 8y plus 20. It's a positive 8y now because we've added it. So to complete the square, we want this to be a perfect square binomial, because for our equation, we need it to be a binomial that's squared. We need to convert this from this type of equation to this type of equation. So we want to make this a perfect square binomial. So we take that middle term, 4, cut it in half. That's 2. And then we square that. And that's what we add. So we add 4 to both sides. And now we know that this is x plus 2 squared, because this 2 becomes that number that we put in the parentheses. And it equals 8y plus 24. This is almost there. We need to factor out to where the y. We need to factor out. So 8y plus 24, x plus 2 squared equals, we can factor an 8 out of both of those. 8y plus 4. Oh, 3. 3 times 8 is 24. Whew. Mr. Brock, you're not thinking straight here. X plus 2 squared equals 8 times y plus 3. Well, that looks a lot like this equation. X minus h squared equals 4p y minus k. Well, here's the thing. There should be a p in that equation. So whatever's in front of the parentheses here is 4p. So that means over here, 4p equals 8. Because in our equation, that's an 8. So if 4p equals 8, that means p equals 2, right? Because divide both sides by 4, p equals 2. So that's our p. Our p is 2. So our equation is x plus 2 squared equals 2p. Oh, I'm sorry, 4p, because it's 4 times 2 is 8. 4p y plus 3. That is the equation of our parabola in standard form. So with that, can we find the vertex, axis, focus, directrix? Absolutely. So we know the vertex is the HK, and the H is found right here and the K is right here. So if x minus h is in our equation x plus 2, what is the h? Oh, I'm sorry, but let me put that a little higher. So that's x minus h, which in our formula, our equation is x plus 2. So if it's supposed to be x minus h, h must be negative 2. Because that's the only way we can have x plus 2 is if we subtract a negative. So our vertex is negative 2. That's what the h is. What is the k? What is the other part of it? Y plus 3. The equation said it's y minus whatever k is. We have the same case. It must be y minus negative 3. So our vertex is negative 2, negative 3. So we got one piece of it done. What's the axis of symmetry? Well, the axis of symmetry, especially if we go back and look here, is this line that's right there in the middle, right? That goes up and down, cuts the parabola in half, and it's always whatever the x coordinate is. This is x equals 4 in this one, because the vertex is at 4, 2. I mean, 4, 0. The x is over at 4, and it's right on the y-axis. I mean, the x-axis. The y is 0. So if it's, and the focus also, the axis of symmetry also goes through the focus. We know it's at 4. So for this one, it's x equals 4 because it goes through the x value. So on ours, our x value is -2. That's where our vertex is. So our axis of symmetry is at x equals -2. That's that line that would go straight up and down in the middle of our parabola. So what is the focus? Well, all we know about the focus and directrix is it's going to be the same distance from the vertex, but the focus is going to be inside the parabola and the directrix line is going to be outside. And it's going to be a y equals something. It's going to be a horizontal line, y equals something. We know the distance between the axis and the focus is 2, because that's what P is. P is that distance between the axis and the focus and the axis and the directrix. So since we know, and again, look at this, since we know that the focus is straight up and down, that point straight up and down from the vertex, it has the same x. See, this vertex is at 4, 0. The focus is at 4, 2. It's just 2 higher than the vertex. Well, same case here. It's 2 higher. So whatever the vertex is at, -2, -3, we need to raise that 2. We got to add 2. -3 plus 2 is -1. So our focus is at the point -2, -1. And we'll graph this in just a moment. We'll look at it. Our directrix is going to be 2 below the vertex. If the vertex is at -2, -3, the directrix is going to be 2 down from that. It's going to be at -5. So we subtract the from the vertex to get the directrix. Now let's look at
Question.
Yes.
Well, so is the vertex like, okay, so the focus is 2 above the vertex, right? And the directrix is always low?
And
Or is it
the directrix is a line. Remember, the directrix is a line, and it is the same distance away from the vertex. It's P distance away.
Oh, okay, P distance away. Okay,
Yeah,
that makes
P
sense.
distance away. And our P happened to be 2. So,
Okay.
so let's throw this on a graph. And we can type it in exactly the way that we calculate it to be. We'll do it the x plus 2 squared equals, and we said 4p, but we'll go ahead and put it in this method. The p is -2, y plus 3. Okay, here is, yeah, I don't like the way this does it. I like it to be by ones. Okay, by ones. So -2, -3. There's our vertex right there at -2, -3, like we said it was. So the focus point would be P distance down from that. So we said, oh, I did that backwards. Why is it going down? This shouldn't be going down. P was +2. That's why the problem. P is +2. I put -2. I shouldn't have graphed that. P was 2. 4 times 2. All right. So we said our focus point was the point -2, -1. So there's our focus point right there. And the directrix we said was the line y equals -5. So there is -2, -5, but it's that whole line. But you notice that the closest point at it, 90 degrees, is a distance of 2 away from the vertex. We're a distance of 2. Whoop, where's it? There it is. So the vertex is halfway between there, as it should be. It should be halfway between the focus and the directrix, and that distance between those is P. So the distance from the focus to the directrix is 2P from the focus directrix, because it's P down to the vertex and another P down to the directrix. So it's 2P. 2P or not 2P, that is the question. No, that's the answer. 2P is the distance between the focus and directrix. So if we can find what the distance is, find P, that tells us where the focus directrix. And they're always lined up with the vertex. So the vertex, you have to find the vertex because the focus is always exactly above or below. If this was a downward facing parabola, these two would trade places. The focus would be down here and the directrix would be up there. If this was a downward facing, if this had a negative P as I started with, we'd have to trade places with those. All right, so that is.
Wait, Mr. Brock, I have one more question. Why does like the focus have to go up and why does the directrix go down? Or is that even the case?
Because the focus is always inside the parabola.
Ah,
The
okay.
focus is always inside the parabola. So in this case, yeah,
Yeah.
again, if this was a negative P, then these would trade places because the focus has to be inside the parabola.
Okay. That makes sense.
Yeah. So, yeah, make sure your focus is inside. So, determining which way your focus goes depending on which way your parabola opens. If this is a left to right parabola, then everything would move in to the left and right of the vertex. The directrix line would be an up and down one. So let's look at that real quick. If we traded this to be a y and an x, let's say we had a sideways parabola, then our focus would move. If it's still a p of 2, and this would be x equals. So if we had a sideways parabola, then we'd put our focus inside over here, and our directrix would be an x equals. It'd be an up and down line, vertical line, if we had a sideways parabola. And again, if it was a negative, it would be facing left, and those would have to trade places, but it's a positive, so it opens to the right. But the focus is always inside the parabola, whichever direction it faces. So
Okay. That makes sense.
All right, fabulous. All right, let's look at, bring this back over here. So this does have in the problem, in the lesson, some check your answer stuff in here. So it still gives you a chance to practice what we're gonna do. So let's try this one. To find the focus and directrix of this parabola. So let's turn our paper over. We'll work this here and just give that a shot. Let me write this down. X squared equals negative 8y. So obviously this parabola has an h and k of 0. They want us to find the focus and the directrix. All right, so if we bring this back up, they gave us this equation. They said, here's the equation of our parabola. And they want us to find the focus and directrix. So to find the focus and directrix, first we need to find the vertex. And we need to know what P equals, because that's how far away from the vertex the focus and directrix are going to be. So we know that the vertex is HK. And looking at this equation, H and K must be 0 because we don't have X minus H and Y minus K. So the vertex must be at 0, 0. So that one was the easy one. P is not hard either because we know that the standard equation, if it's equal to 0, equals 4py. So since it equals 4py, and this equals negative 8i, that means 4p must equal negative 8 because those are in the same place in our equation. We have negative 8 before the y, and we have 4p is what it simplifies to. So if 4p equals 8, divide both sides by 4. P equals negative 2. So our P is negative 2 for this equation. This is a negative 8, so we know it's a downward facing there. So if the P equals negative 2, the focus and the directrix, the focus is going to be below the vertex because this is a downward facing. This is a downward facing parabola because of the negative. P is less than 0. That tells us it's going down. P is less than 0. So if we add -2 to the y, our focus will move down to 0, -2. All right, so let's look at that on a graph real quick. Let's put that over here. We just have x squared equals -8y. That was our original equation. There's our downward facing parabola with a vertex at 0, 0. We said our focus now is at 0, comma, -2. So there's our focus. And we notice it's a distance of 2, which we said our p is -2. So that's a distance of 2. And so the directrix has to be 2 higher than that. It has to be y equals 2. So our directrix has to be the same distance. So our vertex is exactly in the middle between those 2 points. So our directrix would be at y equals 2. So that's the answer. It was wanting us to find the focus and directrix for that equation. And we're able to do that by finding how far and the vertex. That's how far those are. So since it's a downward, we know it's up and down. The focus will be inside. Focus will be inside. Directrix will be outside. All right. Let's see if there's anything else we need to look at this. We've got another lessons to look at too here.
How do you know when it's going to be a horizontal parabola or a vertical parabola?
Good question. Let's go back and look at this. It depends on the equations. If it's a vertical, you've got the x squared. If it's horizontal, then you have the y squared.
Oh, okay, that makes sense.
So that will tell you which way it's going. And of course, you can always put it in Desmos if you're not sure and just actually look at it. But yeah, you can tell from the equation whether it's a y squared or an x squared, whether it'll be a vertical or horizontal. And then the p will tell you if it's to the right or the left or up or down. So p is larger than 0, p is less than 0, p is less than 0, p is larger. So yeah, that will tell you if left or right, up or down. All right.
And then you print. What did you print?
So this is the example we just did. X squared equals 8y. You can always click on there and check your answer. It'll pull us up. Compare that to x squared equals 4py. So we figure p is -2. So the focus would be at 0, -2, and y equals minus -2, which would be 2. Y equals 2. So it does let you check your answers, give you some practice problems there, and check those. This one is right there, so that'll give you the answers for that. So I'll leave this one, let you have another practice. Now here's a little chart that you may want to copy and paste this. You may want to write this down in your notes. You may want to print this page or whatever you want. This little chart is a nice little summary of what we've learned. If the value of p is greater than 0, and it opens, okay, so this is for an equation that has a y squared. See, these first two are y squared. So this is one that opens right and left. So it says, this opens to the right if p is greater than 0. And here's how you find the focus. You take the vertex and you add p to the h. And the directrix, you subtract p from the h. And that will give you the focus and directrix. You add the p, subtract the p. If it opens to the left, then your p is less than 0. But you still do the same thing. You add to the h or subtract from the h. So anytime it opens to the left or right, you add and subtract p to the h value of the vertex to find the focus and directrix. If it opens up and down, which is the second half of the chart, the bottom part of the chart, that means you have an x squared equation. You add the p to the k and subtract it from the k for the directrix. So that's how you find the focus and directrix. you have to know the vertex and the value of P. And once you know the vertex and the value of P, this little chart tells you where to add and subtract that value to get the focus and directrix based on which direction your parabola faces. So it's not a difficult thing. You just have to pay attention to the details. The details of the equation will tell you if it opens up or down. And the value of P will tell you if it opens left or right or up or down. I mean, up or down or left or right. And then based on the equation and the value of P. And then this little chart helps you keep it straight. And you can always put it on a graph, put it on Desmos, put your focus point on Desmos, put your directrix line on Desmos and see, does it look right? Is my focus point inside my parabola? Is it the same distance from the vertex as my directrix line? If they're not the same, then something's wrong, right? I don't have my focus in the right place. I don't have my directrix line in the right place. Maybe my parabola is graphed wrong. But if you have the equation correct in Desmos, you should be able to look at a graph and say, did I do it right? Way to double check yourself. So, all right, when you get to the bottom of this lesson, you can ignore all of this. This is using an online textbook. It tells you what pages to do. We're not doing the online textbook, so you can ignore. When you get down to this gray area, that's the end of the lesson. So let's look at the assignment for 6.01 real quick. It is just 5 multiple choice questions. 5 multiple choice questions. Find the standard form equation. Here's some of these that give you the focus and give you the directrix. And want you to go backwards and come up with the equation. So let's look at one of those real quick. Just because it goes a little different. Let's work one of these together. So let's say we're going to do this one. We know we've got to find the equation for this. And the equation would be the x minus a, or let's see, no, this is a directrix of x equals. So that means it's a vertical line. If we graph that, let's say we're looking at it, we're like, okay, I don't understand for sure what I need. Let's just graph those two things just to get a visual picture of where these are. 7, 0. Oh. So there is the focal point, and the directrix it says is x equals -7. Oh, look at that. It's an up and down. So this is a parabola that opens to the right. We know it's a y squared because when we look at those two things we graph, the directrix goes up and down. It's a vertical directrix, and the point is over at 7, 0 as a focus point. So it goes to the right. We also know that the vertex is going to be halfway in between these. It's going to be the same distance. Well, if this is at -7 and this is a +7, our vertex must be at 0, 0. So we know our h and k are going to be 0 for this one. So let's go back to this. So we know the vertex is halfway between those, and it's going to be at 0, 0. So that's going to simplify our equation. We know it's a y squared. So this is going to be just y squared equals 4px because this is 0 and this is 0. So it's just y squared equals 4px. So that's the equation we're looking for. Y squared equals 4px. So all we need to know is p, right? Well, we know what p is because we know that the distance between these two is 2p. This one is 7 away from the vertex, and this one is 7 away from the vertex. So 7 is equal to p because that is the distance. That's half the distance between these two, but that's where the vertex is located in halfway. So y squared equals 4 times 7x. Y squared equals 28x. So that's what we should look for in our problem. Oh, where'd it go? There it goes. Why do we not have a y squared equals 28x? Oh. No. I still don't get it. Did they rearrange it to be a y? No. Y squared. This has y squared equals 14x. But it is 4py, and we know the p is a. Are they looking at the alternate? See, they're tricking us. They use the alternate definition of the. Let me go back, show you this. I'll show you what they did. They went to this. Remember, these are the same thing. They did the x equals 1 over 4p y squared. They did the other form, 1 over 4p y squared. They did the other form of the exact same equation. So if our p is 7, x equals 1 over 4 times 7, 28. They gave the answers in the other form, the form that we don't use as often. So now we look for 1 over 28 y squared. It's that one. Same equation as y squared equals 28x. They just divided both sides by 28. They used the alternate form of the same one. So, all right. Yeah, I want to leave. I don't want to submit. I didn't do the rest of the problems. Let's look real quick at ellipses. Ellipses are similar. It's just another one of the things we can get from the conics. So an ellipse is like an oval shape, right? We call it an ellipse is the mathematical term for it, but it's oval. If we go here and we look, I'll show you this in a second. Let's look at the definition first. An ellipse is the set of all points, x, y, the sum of whose distances from two fixed points is constant. An ellipse has two focus points. And if you add the distance between this point and those two focus points, it's always going to be the same distance when you add those two together. And that's the definition. A circle is the set of all points, the same distance from one point, which is the center, but an ellipse has 2 points. This is kind of cool. I'll show you this. All right, so this says the distance from A to F1 plus the distance to A to F2. So the distance from A to F1 is 4.54. The distance from A to F2 is 1.46. So it equals 6. When you add these two distances together, they equal 6. Now, if I move A over here, F1 is only 1.17 distance from A, and F2 is now 4.38, but they still equal 6. Doesn't matter where I move this point, it always equals 6 when you add those two distances together. And if we take it all the way around, we see it makes an ellipse. Makes an ellipse, and it's always a total of 6 when you add those two distances together. 2 focus points. 2 focus points. So it's kind of cool illustration. It's a lot easier to understand it if we put it here on this little chart like this where we can see that. See, there's exactly halfway. That's right there on the minor axis. See, there's 2 axes of symmetry for an ellipse, 2 of them. One of them goes up and down, one of them goes left and right. So in this case, since the center is the origin, the y-axis is an axis of symmetry, and the x-axis is an axis of symmetry, because either one of those make a mirror of the shape. Now, in an ellipse, we call the longer axis of symmetry the major axis, and the shorter one the minor axis. So since this ellipse goes left and right, some ellipses, it could be a taller ellipse than it is wide, and this one's wider than it is tall. It can go either way. So let's go back here and look at this. All right, so it shows the major axis, the minor axis, like we were talking about, and there's 2 focus points. And you look at this. So here's the standard equation of an ellipse. All right, I'm gonna write this down too. This is a standard equation, and this, when the center is the origin, again, the center this time is HK. That's the center of your ellipse. So if it's centered on the origin, this gets simpler because these are zeros. So then it's just x squared over a squared plus y squared over b squared equals 1. That's when the origin is 0, 0. When the center is 0, 0. Center is the origin. Right. And so this is a horizontal major axis. So this one would look like that. Major axis is horizontal. Right. Same thing here. Mine looks more like an egg than an oval, than an ellipse. If we have one that is vertical, let's do the equation for a vertical ellipse. The major one is vertical. Then what happens is we switch. I'm going to do these with the x minus h again. X minus h squared and the y minus k squared. But what happens is these trade places. And A is larger than B, always. A is larger than B. So if the larger number is on the left, then it's going to be here. If the larger number is on the right, then it's going to be an up and down. So it just depends on where the larger number is. And of course, this simplifies to x squared over b squared plus y squared over a squared equals 1. Up and down. So you just have to look and see where is the larger number. And that'll tell you, does it go up and down or does it go left and right? Okay.
Okay, so we're trying to prove.
And the two focus points, the foci,
Look at this.
plural of focus, are on the major axis, are on major
Perfect. Well, so that's what we need.
axis,
You know,
which is the longest. Major axis is whichever one's the longest, right? So on this one's up and down, and this one's left and right. That's where you will find the two focus points. They're on the major axis. And we do have with the a squared and the b squared, a squared plus b squared does equal c squared in this case. The Pythagorean theorem applies in here. And that c, we'll use that c here in just a moment there. Write in the equation, to write the equation, you got to know h and k and a and b, obviously, right? H, K are the coordinates of the center. That's always important to know. So the center will always be the midpoint between the foci. And there are vertices. So this is a vertex and this is a vertex. Write those on there. See, there are two vertex for an ellipse. And the foci would be in here, right? Put those points in there, foci. So we got the two foci that will be inside there, and they will be in line with the vertex. They will all be on that major axis. They'll all be on the axis. And the distance from the center to a vertex and focus are A and C. So the distance from the center here, let me make this bigger. So we have the major axis, and we have the vertex, and we have a vertex, and a focus point. And then here's the center. So the distance from the center to this focus is C. And the distance from the center to the vertex is A. And we find out what the a squared plus b squared equals c squared. That's how we get c. Like, okay. Looks a little crazy, but let's see if we can figure this out. So let's try to work a problem. In this problem, they're going to give us the vertices. And the vertices are 3, 0, and negative 3, 0. Okay, so there's our two vertices, 3, 0, and negative 3, 0. And the foci, they're going to give us the foci points, are at 2, 0, and negative 2, 0. Okay, so since all these points are on the x-axis, 3, 0, negative 3, 0, we can look at that real quick. Let's take these points off. So if you just graph those points because you want to know, get a good visual of where they are. Negative 3, comma 0. Oh, comma 0. And 2, comma 0. And negative 2, comma 0. All right, and we'll label all those points to show us where they are. So since these are the focus points and the vertices, we can see this must be an ellipse that is left to right, longer than it is tall. And the center must be right there in the origin, right? That's got to be where the center is because that is the middle of those points. So we know that our center is 0, 0. We've learned that. So what is C? Center to the focus. Well, the focus is 2 away on both sides. So our C must equal 2. Center to the vertex. This is 3 away from the origin. This is 3 away from the origin. It's just the other direction. So our A must equal 3. Okay, we're getting close. We know our equation is going to look like this one because it's wider than it's tall. So it's x squared over a squared equals y squared over b squared equals 1. We've got a and c, but we know we can use this equation. So if a squared plus b squared equals c squared, if we fill in what we know, 3 squared is 9 plus b squared equals 2 squared is 4. All right, see what we got here? Am I doing this right? Am I doing this like I wanted to do this? I think so. I don't know if I have any good examples of that written down. So b squared equals negative 5. Well, that doesn't work. It has to be a positive because we're talking about distances. So when I'm putting that in there, we know it's a distance.
Okay, go back to your 22.
Oh, I think I have that. I think I wrote that down wrong. Oh. This is a minus. A squared minus b squared equals c squared. This is not the Pythagorean theorem. A squared is always the larger number, remember, the larger number. So the a squared minus the b squared is going to equal to c squared. I had that written down wrong. Please correct that in your notes if you're taking notes, sir. A squared minus b squared. So that changes everything. A squared minus, let me change this. Negative b squared, negative b squared. Negative b squared equals negative 5. So we divide both sides by negative 1. So b squared equals 5. So b equals the square root of 5. But b squared equals 5. So if we're writing our equation, and we know it's going to be like this, x squared over a squared, well, a is 3, so that's 9, plus y over b squared, plus, I'm sorry, y squared over, well, b squared is 5. We got that right there. Equals 1. That is the equation of the ellipse that has these focus and vertices. Let's put that in our graph and see if that's what it actually looks like. X squared divided by, not just the squared, divided by 9 plus y squared. Oh, wait. I don't want it under the 9. Okay. Plus y squared divided by 5 equals 1. Look at there. There's one vertex. There's the other vertex, exactly where they're supposed to be. And these are the focus points. Now, we'd have to do some fancy measuring to make sure that's the same point around, but that looks correct. The focus points are inside the ellipse. They're the same distance from the center. The center's 0, 0 in this case. They're the same distance from the center. They're on the major axis of symmetry. So it looks like we have our equation correct. And in fact, if we, this was the problem from our assignment, find the equation of ellipse with vertices 3 and -3, 2 and -2. Check your answer. So if we go to check our answer, x squared over 9 plus y squared over 5 equals 1. That's exactly what our answer was. So we did that correctly. So, all right, down here, there's a couple more for you to practice. Down here, this has another chart like we had on the other one. With the center HK and it's parallel to the axis. The major axis is parallel to the x-axis. That means it's wider than it is tall. Here's what the equation looks like. And here's how you find the two focus points and the vertices. You add the C to the H value to get one focus, and you subtract the C from the H value to get the other one. For the vertices, you add A and you subtract A. And those are all from the H. If you have one that's parallel to the y-axis, it's taller than it is wide, then you add and subtract C from the K value and add and subtract A from the K value. And that'll find the two focus points and the two vertices. All right. Gosh, I've kept you guys an hour, but we had a lot to look at on there. So that is the big picture of ellipses and vertices. Now you can go through those two lessons and see some of those other, we didn't try all the problems, so you can check your answers in the lesson and see if you're understanding there. But otherwise, that's all I need to show you. I will tell you Friday is the state bowling tournament. And since our team qualified for state, I won't be here Friday, but you can email me if you have questions. I'll try to get back to you. You can email me. We meet tomorrow if we need to. So that's it. That's all I'm going to throw at you today, unless you got questions. But all right, you guys go have a wonderful day. We'll catch you next time.